In this video, we will be discussing scalar functions. A function is a predefined block of code that may or may not accept an argument and must return a value. Scalar functions are functions that are executed once for each row, and they can only return one result for each row. Scalar functions operate how functions typically do in programming. Scalar functions can also be thought of as single row functions. There's another type of function in SQL Server called an aggregate function, which we'll cover in a later video. When using functions, we can call functions on other functions. Functions can be the input to another function. When this happens, the innermost function is resolved first. So the innermost set of parentheses gets resolved first. Typically when we build these, we want to build the innermost set and then put the next function around it and then put the next function around it because it's easier to test to make sure it's working when we build it that way. However, the order that they're resolved in is that the innermost gets solved first, then it works out, then it works out. That'll be easier to see when I do the demo. SQL Server has a variety of types of functions. This is by no means an exhaustive list of functions available in SQL Server. These are just some very commonly used ones. Functions are not part of ANSI standard SQL. That means that the functions that are in SQL Server may or may not exist in other database systems, and even if it has the same name in a different database system, it may not work the same. So when it comes to using functions, you truly have to understand how each system's functions work. I'm going to go ahead and switch over to the demo now. I've gone ahead and brought over all the functions here and set this up to make life easier and not switch back and forth from the PowerPoint constantly. So we're going to look at the employee table here for our string functions. There's a lot of good examples that we can use from the employees table, and it's a relatively small table. For our string functions, these operate on any character fields. So chars, varchars, nchars, and nvarchars. We're going to start with the upper and lower functions. These change the case of a field. So if I want to look at the employee's last name, I can also change it from sentence case, which is what it currently is in, into both uppercase and lowercase. So in order to do that, in my select list, I say upper, I use my parentheses, and the input to my upper function is going to be the e.lastName column. That's what I want to make uppercase. And then I could do the same thing with lower e.lastName. And I didn't include any column aliases, so my column headers come out as no column name. That's okay for this application. So the first column is the normal last name as it is in the table. The second column is the uppercase last name. The third column is the fully lowercase last name. Now in SQL Server, there is no sentence case function. So if you want to do that, you have to piecemeal things back together. The next function is substring. This takes a piece of a string. So if I want to see the employee's first initial and their last name, I can do that with substring. e.firstname from employees B. Back in my select list, comma, I'm going to do substring e.firstname. And you'll see that as I do this, Management Studio is prompting me with what goes into the arguments for this function. So the first item is the expression, what it is I want to substring. The second one is the starting position. Where do I want to pick apart the string? If I want the first character, I'm going to start at the beginning, so position 1. Note, SQL Server is 1-based, unlike most programming languages which are 0-based. This might be confusing, but keep in mind it starts at 1. So start at position 1, start at the first character. If I want the employee's first initial, I go for a length of 1. Start at character 1 and give me 1 character back. And add some comments here. Display the employee's first initial and last name. Now I'll include the last name. And when I run this, first initial, last name, we can see the first name just to show that it actually did pull the first initial off the first name. Now, if I want to accomplish the first initial, I could have also done this using the left function. I'm going to copy paste here. So the left function returns any number of characters off the left side of a string. So I would do left e.firstname1, and it will return me the exact same thing. Now there's also the right function. The right function will return X amount of characters off the right side of the string. So let's say I want to, for some reason, display the last character of the employee's first name. Not that this is a particularly useful application, but it'll get the point across. So from the right side of first name, grab 1 character. Start on the right side, pick the first character. So for Nancy, it's Y, Andrew, it's W, and this shows that it goes down the line. So let's look at the len function. Len returns the length of a string. So I'm going to display the employee's first name and the number of characters in it. So len first name as chars in first name. So Nancy contains 5 characters, Andrew contains 6, so on and so forth down the list. Let's talk about replace and format, and then we'll go ahead and look at some of the others because they work better with multiple functions put together. So if I want to look at, let's look at an example. Let's say I'm looking at adjusting job titles. And anywhere that we have shipping/receiving, I want to just call it shipping instead. We've decided to rename the department as shipping. So I want to replace shipping/receiving with shipping only. So I'm going to display the e.firstname, e.lastname, e.jobtitle. So then we're going to do replace. So the replace function requires 3 arguments. The column I want to look at, so job title. What I want to replace, so what I want to find shipping/receiving. And I want to replace it with just simply shipping. And I'm going to call this new job title. So the way the replace function works is if it finds this text, it will replace it. If it doesn't find that text, it will just display what the original column was. So we can see for the majority of these, nothing changes. So when I get to the people that work in shipping and receiving, it went from shipping/receiving to shipping. So shipping specialist, shipping manager, so on and so forth. So that's how replace works. Now the format function is a newer function, and it can be used to format dates. It could be used to format numbers. Let's display this with dates first. So I'm going to just start by selecting the hire date from the employees table. First name, the last name, so the default way that SQL Server shows dates is year, month, day. If I don't want it to display that way, I can use the format function. Now format is a newer function, as I said, which means it's not available in all versions of SQL Server. So I want to format the hire date, and let's say I want to do month, day, year, and I want a 4-digit year. Or I have to do this in lowercase. There we go, lowercase. So this reformats my date with slashes, so because I indicated slashes. So 1992, 05, 01 became 5/1/1992. I could also flip this around and do the day, month, year if I'm in a European date format. Or I could use slashes or dashes or dots or anything I want to separate my date pieces as well if I'd like to. Let's format with dates. I'm going to quickly show you format with numbers. So I'm going to move over to the products table. So let's show the unit price and the profit margin, and we're going to format them. So let's include the product name from products, P dot product name, P dot unit price, P dot unit price minus P dot wholesale price as profit. And these come out okay, but maybe I want to see them as currency. So I can format this as currency. So around this calculation, I'm going to say format. First argument is that calculation. If I want currency, I can put a C in single quotes. Now it's formatted as currency. If I want to see it as a number with additional decimal places, or without any decimal places, I could do that as well. So let's say I want to format the current or the profit as simply a number. Number is n. And that just goes by default and kind of picks how many decimals it should have. I can also specify how many decimals to include by putting it after the n. So if I wanted 4 decimal places, I would say n4. And that would change it to have 4 decimal places. So that's my format function. Let's talk about replicate and concat. So let's go back to our employees table. Let's say we want to display the employee ID as a 5-digit number with leading zeros. Well, let's figure out how we do some of this before we put it all together. The replicate function displays something a certain number of times. In and of itself, that's not particularly useful. I can replicate a 0 5 times. And it gives me 5 zeros. But if I want to replicate the employee ID, let's add that together. Select from employees, P. I'm going to pick the employee ID, replicate. Let's add some zeros there. 5 zeros plus the employee ID. When I run this, I still get the same thing. Well, what happens is with my plus symbol, because employee ID is an integer, which I can see when I hover or if I go into the table, 0 plus a number does math instead of concatenation. So we have our concat function that can help with concatenation. I'm just going to add some comments here. Copy paste. So I'm going to do a concat. So concat concatenates, and it does some nice things for us. It handles nulls, it handles changing the data types on arguments so that they work. So now when I do this, I'll see I get 5 leading zeros. But that's not really what we wanted. We wanted a 5-digit number. So we're getting closer. We're going to keep going. Remember that length function? But if we want 5 digits, we only want to replicate however many 5 minus whatever the digit is of the ID. So if there's 1 digit in the ID, I want 4 zeros. If there's 2, I want 3 zeros. So let's keep building this together. Let's add the length of the employee ID. So we can see that. It shows us the accurate one. So what we actually want to do is we want to replicate 0, but we don't want to replicate it 5 times. We want to replicate it 5 minus however many digits are in the employee ID. So minus the length of the employee ID. So now when I run this, I always have a 5-digit number here. So that would give me the employee ID as 5 digits with leading zeros. And that's how we can kind of build our nested functions. So in this case, I have the innermost is this length function. Length gets passed to replicate, and replicate gets passed to concat. So I have three nested functions here. Now let's talk about char index and pat index and show how these can be used together. So both char index and pat index will find the position of a character in a string. So let's start by looking at the employees' phone numbers. Select from employees, E dot phone, home phone. Let's look at home phone. We can see there's an area code or country code or something in here. Let's pick this apart. Let's put the area code in one column and the number in a separate column. So what we need to do in order to do this is use either char index or pat index to figure out how to split this string apart. We're going to have to be able to split this based on this closed parenthesis. So we want to figure out where is the closed parenthesis. I can use char index. So char index is, we start with what we want to find. So I want to find the closed parenthesis. I want to find it in the home phone field. And it's an optional start location. I just want to start at the beginning, so I'm going to just exclude that. So this tells me in this string, closed parenthesis is at position 5. In the next one, a couple down, the closed parenthesis is at position 4. I could also have used the pat index function that does a pattern search or a wildcard search to find something. So it could be more than just a single character. So same numbers, different function, slightly different syntax. Pat index does that pattern match or that wildcard search, kind of like a like statement. Our search string here is like a like statement. So we figured out where this is. Now we have a function that we've used that can pick pieces out of a string. It's our substring function. So we're going to start with that. I'm going to substring the home phone. I'm going to start at the beginning because I know I need to start at the beginning for the area code. And I'm going to go until I find this closed parenthesis in each row. And that's the char index of the closed parenthesis in the home phone. So let's start there. Let's see if that works. And it does. It returns us the area code. Okay, so we got the first part done. And this works regardless of if there's a two-digit or three-digit area code. So the next piece is the number. Well, the number has to start somewhere after that closed parenthesis. But we don't know what it's going to be. We don't know what that digit is. The only thing we can guarantee is that it's after the closed parenthesis. So we're going to do another substring. We're still going to substring the home phone field, but we're not going to start at the beginning. We know where that parenthesis is, so let's start there and see what happens. And let's just say we're going to go the length of the field. Well, that was close, but not quite. So when we said start at the position of the closed parenthesis, it literally starts at position 4 or 5 here, which means it would include that parenthesis. So after that, we've either got a space or in some cases we have a dash. So what I'm going to say is I want to start at the char index of the closed parenthesis plus 2 characters over. So move over 2 and then pull it. And now we're all substringed correctly. So we've got our area code, and then we've got our phone number in the next column. So this shows how we can use functions together to break pieces of a string apart. And that should cover all of our string functions. We missed ltrim and rtrim. Ltrim and rtrim are pretty easy functions. Basically what they do is trim white space off. So for instance, if you have users inputting data into a form, they might have leading or trailing spaces. Ltrim trims the space off the left-hand side. Rtrim trims the space off the right-hand side. So I'm going to create some situations where there is space and then show you that it trims it off. Let's select 3 spaces plus e.first name. And then I'll add it on the end as well. So the space on the end is difficult to see. If I copy this out, it'll show me that that space is actually there. So when I test this, I'm going to make sure that that space is missing. So I could do an ltrim on that, and I could do an rtrim on that. So we can easily see that the ltrim trimmed the space off the left-hand side. If I copy one of the ones of the rtrims out, I can see that it did, in fact, remove that space. Now if I want space on both ends removed, I'm going to take an ltrim, and I'm going to also take an rtrim, and I'm going to trim that same concatenation. So first it'll trim the right side, then it'll trim the left side. And if I copy one of these out again, just to show you, no space on the left or the right-hand side. That's our string functions. Moving on to math functions. Math functions are pretty easy. So there's the round function, which may or may not remove decimal points. So if I do some sort of math, let's look at the products table. Do P dot unit price minus P dot wholesale price. So the unit price minus the wholesale price, that gives me the profit. If I want the markup, I have to divide it by the wholesale price again. Now I need to put my parentheses in here because order of operations of math. If I didn't put this in here, it would divide by the wholesale price first. So I'm going to include each product. So this is actually a percentage. I could format that as a percent, or I could round it. So let's do a round on that instead. So round, if I want to round it to 2 decimal places, I say comma 2. And in this case, it actually did remove my trailing spaces. Sometimes it does, and sometimes it doesn't. If I wanted to round something to the zeros, let's say I want to round the unit price, Rounding it to 0 would round it to the whole numbers. This still includes my decimal places. It doesn't truncate them. So I'm going to as round to whole number. And I'm going to copy that and show you rounding to the tens. -1 will round to the tens. And I'm just going to include the actual unit price here so you can see what it's doing. So there's our hundredths, our 0 to the whole number, or that's our original. This is our round to the whole number, this is our round to the tens. Abs is the absolute value. So if I did my profit margin calculation backwards, my profit margin should be unit price minus wholesale price. If I did it backwards, I'd get a negative number. I'm going to show you that. Absolute takes the absolute value, which means always the positive portion. And I'm just going to copy this calculation out to show the difference. Let's look at floor and ceiling. So I'm going to include the unit price, and I'm going to take the floor of the unit price, and then I'm going to take the ceiling of the unit price. If I spell it correctly. So when there's a decimal, floor goes down to the next whole number, and ceiling goes up to the next whole number. When we're at a particular number, so when the unit price is a whole number, floor and ceiling return the exact same thing. And then we've got random. So random returns a pseudo-random number. There is a calculation that creates that random number, but for most cases, rand is random enough. So every time I run this, I may or may not get a different random. With a different seed value, I should get a different one. But as you can see, this may or may not work so well in SQL. You may want to use a different program to generate your random numbers. All right, now we're moving on to date functions. There are a number of different date functions, and some of them work together. So I'm going to show you the simple ones, and then we'll put them together. So getDate simply returns the current date time on the server, not on your computer, but as it states on the server. Then we've got the day, month, and year functions. So for a particular date, you can return the day, the month, and the year of the date. So let's look at the orders table. And let's just select top 10 star. We don't need to look at too many rows. We've got order date, required date, ship date. So let's pick the order date. Let's pick the day of the order date, the month of the order date, and the year of the order date. And that returns us the pieces of the date. Now if we look at date part, we can do a similar thing with date part. But date part is more powerful than these simple functions. So if I look at date part, I specify the date part function. It wants an interval. So if I want the day, I say day, not in quotes. And if I start typing, it will give me the options. So I can have day, day of year, weekday, date of the order date. And I can do the same thing for month and year. So instead of day, I can start typing month, and I can say year. And that returns me the same things as before. However, with date part, I can do more than just day, month, and year. I could do weekday. So what day of the week was it that this order occurred on? What day of the month was it? What day of the year was it? So the weekday says, okay, this was a Monday, Tuesday, Wednesday, Tuesday, Friday, Saturday, Sunday. So 1 is Sunday, 7 is Saturday. The date name function works very similarly to the date part functions, except when something has a name, it will return the name of that piece of the date. And when it doesn't, it will just return value. So for the day of the order date, it's simply the day. For the month, we get the name of the month. For the year, we just get the year. For the day of the week, we get the actual day of the week. So that's date name. Now we have date diff. If we want to calculate the difference in two dates, we use date diff. We'll see the difference between the order date and the ship date, how long it took to ship. And let's look at that in weeks. So the starting date is the older date. And if it's less than a whole week, it would show 0. And this may or may not be what you expect it to be because it's not 7-day week, it's weeks of the year. So difference in weeks may not be what you want. You may want to do this in days and then divide by 7 to find the weeks. Well, sometimes the calculations don't come out exactly the way you would think they do. So this gives you very different numbers in some cases. But date diff is used to calculate the difference. It could be days, it could be weeks, it could be years, it could be months, any portion of a date you want to calculate between two different dates. We have date add, and that adds a certain number of days or weeks or months to a date. So I could say date add. My interval, I'm going to say year. I'm going to add 1 year to the order date. And see what it gives us. So it simply adds a year. I could add a month here too. And then it shows me what 1 month later is. If we simply want to find out what the end of the month is for a particular date, we could do that as well. That's our end of month function, or EO month. So if I want to find the end of the month of the order date for shipping or billing purposes, I can do that. For July, it's the 31st. For August, it's the 31st. For September, it's the 30th. Those are our date functions. One last set, our special functions. So is null, that lets us replace a null value with something else. So if I wanted to do, let's go look at our employees table again. When we look at this, we'll notice that some employees don't have a state or region. That can be problematic when we're concatenating. We could replace the state or region with an empty string with is null. So select state or region is null, state or region. So when it's null, let's replace it with an empty string. And we can see that when it's null, we get an empty string instead of a null value. This could also be accomplished with the coalesce function. The nice thing about coalesce is if we have multiple arguments that are null, we can replace them as well. So if I purposely put a null in as the replacement, when it's null, it'll still replace it with this empty string. That's more useful when we have multiple columns that we want to replace with, but we don't have a good example of that in this database. Then we have our case statement. So case can be written two ways, and it kind of works like an if then else. So let's say if the country is US or USA, we want to write United States, and when it's UK, we want to write United Kingdom. Because in our employees table, there's only 2 different countries, even though there's 3 different codes. USA, UK, and US. So I'm going to show you the first way to write a case statement. This is when you select a column. So case, country. When US, then United States. when USA, then United States. When UK, then United Kingdom. If for some reason I have something else, I can have an else clause, else unknown. Then I need an end statement to end my case. You can say USA is United States, US is United States, UK is United Kingdom. So that's the one way to do a case statement. And that requires a particular column. The other way allows more flexibility, and you could use many different columns. So I get rid of that column there, and I say when country equals US. Or, because this is more flexible, I could say when country in US, comma, USA, then United States. And I can get rid of that whole second line. When country equals UK, then United Kingdom, else unknown. In this method, I could refer to completely different columns between two separate pieces of my case. Next is the IIF, if statement, which functions similarly to a case statement. It's a newer addition in SQL Server, so it may or may not work on your system. So I'm going to do a similar thing here. If, but it only works on a single condition. If the country is in US, USA, my true portion, my false portion. Since I know I only have two different values here. So this only works if you have one condition, true and false. If I had multiple different countries I was trying to spell out, I would need to either use a case statement or a lookup table. Now let's talk about cast, convert, try cast, and try convert. So cast and convert change the data types of a field just for our select statement. And they do similar things, but they function a little differently. So let's look at our hire date again. So we've got the hire date. Prior to the format function, the only way to reformat a date was to use the convert function, because it has an option for date format. So I could have done convert. I convert it to a varchar. I want to convert the hire date, and I'm going to give it style 101, which is our traditional English or American date. And that reformats it. Now, the date formats are all available online. If you look up Microsoft SQL Server Cast and Convert, you'll find a web page that'll give you all those formats. I can also use the cast function, but that doesn't change the format for me. It just would return it as a string that I could use to concatenate with. So the format of this is a little different. Cast hire date as varchar, and in this case I should give it a length. Varchar 10 for a date. And in this case, it does the same thing. It doesn't look any different, but it's actually a varchar instead of a date. Now, this is all well and good until you try to cast or convert something that isn't actually a date. So if I try to, I'm going to grab this function, cast and convert here. If I try to convert a non-rail date, so let's try 2/31/2018, clearly no February 31st. And I'm actually going to run these separately just to show you that both of them fail individually. Actually, this one may fail, the other one may not. So let's try to cast this as a date instead. Because as a string, it'll take anything. So I try to convert that to a date, I get an error. And the same thing when I do the bottom. But if I do the same thing, but do try convert and try cast, I just get nulls. It couldn't do it. But when I do the same thing in here, so I do a try convert from a valid date, let's do February 28th, and a try cast of a valid date, first argument is null because it couldn't do it. The second one gives me a value, so it doesn't actually error out. These are also newer functions for SQL Server, so they may not be usable in all versions. And that is the end of our special functions and the end of our scalar functions video. In the next video, we'll talk about aggregate functions.